there it is, the Mega Lithophane. This is my Mega Lithophane project. I had a 55-inch LCD TV that had broken, but the backlight still worked. So I took it apart, removed everything except the components directly related to the backlight and the power supply, and I replaced what used to be the LCD screen with a series of 3D printed lithophane panels to make this cool longhorn pattern you see here. It's about 10 or 15 pounds lighter than it was when it was a full-blown TV. There are no other lights on in this room. It literally just fills the whole room with light. I'm very impressed with the output. And the camera really does not do it justice. Look how much darker the background got there just because of the camera compensating for the brightness of the light. Here's a quick look at how the setup is put together. I've got the original metal frame, the main frame from the TV here in the center. This is the glass part of the backlight. It's basically a pane of glass with some reflective material on the back. And around the perimeter, these are the LED strips that illuminate the backlight. There's one along each side, and the corners are where they plug in to their wiring here, which then goes to the power board. And then these several sheets of material in the same order they were originally on the TV that kind of diffuse the light. Those are just held down with tape along the sides. And these main holes through the frame are how I'm bolting everything together, and then the plastic face cover on top of that. The TV had several different PCBs in it. This is the only one I'm keeping because it handles the power distribution. This is where the main wall AC plugs in, and over here all of the different LED strips plug in. So when I plug this into the wall, it just turns itself on. I'll probably throw a switch in there somewhere. There are 30 different panels, each about 9 inches by 4 inches. There's holes drilled in each corner so they can be tied together with fishing line, and just used a square knot there. If you don't know what a square knot is, just go ask your local Boy Scout. Just want to give you an idea of the level of detail here and the scale too. This is a 55-inch TV. His face is about as big as my hand. I'm going to go back and trim the excess fishing line here. I printed the panels vertically like so because these FDM printers have a better resolution in the X and Y directions than in the Z. They're about 9 inches wide because that's as wide as I can fit on my print bed, and about 4 inches tall because any further than that and I started getting some distortions in the top. This is one of the panels that I printed a little taller than the rest, exactly double actually, and you can see this distortion here, which I was trying to avoid by making them shorter. That's caused by it having kind of wiggle room and sway when you print such a tall and thin object, so I'd recommend printing these with a raft or just doing them in short sections. This will be covered up by the final framing, so I'm not very worried about it. I plan to go back and replace a few of these panels over here. You can see they're not quite the same exact shade of white. That's because I didn't use the exact same brand and type of filament for the entire project. Here's how I printed these parts. I did them 2 at a time, diagonally like this, how they fit on my print bed. And over here you'll see the settings I used. It is 100% infill, totally solid. And then the other important thing, I'd recommend you use a brim to help with bed adhesion since the base is so short on these. I did them 2 panels at a time, 30 panels total. It took about 10 days or 240 hours of continuous printing to finish all of it. It ended up taking more like a month because I didn't run it on 100% duty cycle, but in the end it used about 2 full kilograms of filament, and it took me about a month to finish printing all of these panels. So let me show you how I made the STLs. I used this website called itslitho.com to generate the actual STL files that you can print. What I did is I started with a high definition image of what I wanted to make, and I split that into a bunch of small enough parts to print on my printer. I scaled it to match the aspect ratio and the size of the TV, then split it up into manageable parts, because if you tried to convert the entire image into a full-scale lithophane all at once, you'd be dealing with a massive file that would be extremely difficult to handle with CAD and with your slicer software. But these are the settings I used here. I just set the width to what I wanted, and I did a no frame. That'll add kind of a thick border that you don't want if you're stacking a lot of these. There are lots of different websites you can use like this one, but this is just what worked for me, and I was pretty happy with it. Another note here, I did print this on the biggest layer height I could on a 0.4 nozzle just to save time. This was about a month worth of printing every single day. It would of course turn out a little better if you wanted to use maybe a 0.2 nozzle with a finer layer height, but at that point I was really approaching the limit of the pixel density of the image itself rather than the limitations of the printer. So I would recommend just sticking with a 0.4 nozzle for something this big, and there's not necessarily much of a reason to go with a super fine layer height.